Hello there, fellow nerds. Welcome to the Land Tamer stream on this Sunday. It is 3 p.m. Eastern, and we're going to get started on a quick vlog and then talk about QoS shaping, a continuation of kind of where I left off recently on doing some labs. So we'll talk about a couple things. Unavoidable life distractions happens to everyone, right? This weekend has not gone according to plan. Sure enough, my plan was to begin actually yesterday. Hit the anki workbook, start going through each of the labs there in the QoS section. Has not happened due to a couple things. One is an unforeseen issue that I had to help out with, work related. So that took up Friday evening, part of Friday evening, yesterday, good part of yesterday morning. So yeah, that was a deterrent. And then also my wife, she's going to be starting keto. I've been doing keto diet for over a year, and so I'm trying to be a support to her to start that. It's not easy to get started. It's great once you get it going. So anyway, I've been helping with we've been doing purchasing groceries and already doing some meal prep. I did some preparation a little earlier. Probably have to do some more tonight to help out with that. Generally, it's really easy for me. Like, I work from home. I generally tend to cook as I go. Like at lunch, I'll cook a meal. After work, I'll cook a meal, and I'm good to go because I'm right here. She does not work from home, so I'm going to be helping with some meal prep beforehand. And the weekend is a good time to do that if you do anything like keto or paleo, which I've done. Now doing keto. But anyway, that's health related. It does take time. I'm learning too. I'm going to do some baking, things I've not tried before to make it hopefully a little more appetizing. And then we had our last workout of the CrossFit Open on Friday evening. So it was rough, folks. Let me tell you, I am sore, still very sore. It was a 20-minute workout, and it was intense, and I thought I was going to die. So anyway, moving a little slow, but that and taxes also, trying to make progress on that. I haven't done a lot with that yet, but I'm going to be doing more of that. So there's so much going on right now this weekend. March has just been crazy for me. So trying to get labbing in where I can. I have been, I'll talk about that in a minute, Anki cards. Another subject that has come up is, as I've been searching for recipes, things like that, and even technical information lately, browsing is getting harder and harder. Searching, let me just say that, searching and browsing. Your basic core tenets of what the internet is for is getting so much difficult these days. It's rare for me to go to a site that has any content that I want, except for like Microsoft or Cisco, where there's so many ads. And aside from that, the ads are pretty intrusive on your processor. And it's gotten so annoying that it said, okay, I don't really like doing ad-free browsing, especially for people whose content I want to support. I'm someone like that, right? I'm a content creator on the internet. I'm not doing it for to sustain myself economically, and a lot of people out there are, and I like to support them, but one or two ads is okay, and I understand the challenges of people who are trying to make a living by publishing content. I don't know. Maybe it's just maybe it's another phase that we're going through in technology and internet where I don't know. It's always a tug of war, right? And what's happening, I think, unfortunately, is content creators are not getting either. There's so much competition out there. There's so much content out there. It's hard to distinguish oneself. That to maintain oneself. Oh, Subnetwork is now hosting us. And we got the little thank you for that, Subnetwork. I appreciate it. Thank you very much for that, host. Hats off to you, sir. Or madam, if I was wearing a hat. Derps Enterprises, I have no ads on my website and YouTube. Yeah, that's great, man. I mean, I think I have monetization disabled on YouTube as well. And I get it. I think it's fine to an extent. Like for a while, I had YouTube Red, YouTube Premium, I think it's called now, and I paid a little extra money because I want to be able to download um, videos. And well, my wife wanted to be able to download videos. She's like English lessons. She's doing great with her English, by the way, but she's getting more advanced and want to be able to listen to those on the road. And that was nice because anytime you go to YouTube, you never get any ads. We've since unsubscribed from that. And it's okay. I'm fine to watch an ad here and there. Some people do. Some people who are producing great content live on the revenue from that content, and I'm happy to support them. I also subscribe to people on Twitch because I know if they have great content, I want to support them. I want to encourage them and help them keep going. So the sub network, I love the channel. I'm trying to do something similar. I don't look at similar streamers as enemies but allies. I do the same thing, sub network. Thanks again so much for the host. Hope you had a good stream. I also try to support, I think you all may have known from, I think it was Wednesdays, where I was trying to hype, a new streamer, YouTube streamer. But he reached out to me when he was getting started on Twitter, and I did nothing but try to encourage him and give him, tips. And absolutely, and that's the way you have to do. And I've noticed that a lot of professional streamers, they are by far supportive of each other versus, adversarial. As a matter of fact, a lot of the even the men, like they're sweet streamers to each other. I've noticed, even like the hardcore gamers, they're very supportive of each other, and they host each other. They stream together, which I think is great. Derps Enterprise, I have YouTube Premium now. Got tired of a 30-minute ad from a 3-minute video. Seems unbalanced. I think you're touching on something there, Derps Enterprises. That's the key. Is the balance is way off. So I'm not gonna do it for all sites or searches, but I downloaded Opera and I've used Brave before on this channel, and especially I have a slower iPad. I have an old iPad, and I was trying to get some keto recipes earlier today, and I just got so fed up because you have to scroll, click close, click close, click close. And my iPad's slow, and I just couldn't get to the content. I just put it down. I was like, so anyway, I don't know what browser you use. I'm open to suggestions, what you think is best. I don't want to purchase an ad blocker necessarily. But yeah, just for searching, I'm switching to Opera for now on some devices. Anyway, that being said, getting back to a little QoS study, despite having a lot of distractions the last few days, one thing I have been able to do as a constant is go over the Anki cards, my flashcards. And that's been great because I've incorporated into the flashcards configurations. So it's been prompting me every day for, how do you configure a 2-rate, 3-color policer? And I'll actually open, Visual Studio Code and just write it out, and then I'll show the answer on the card, and that's been getting me more and more proficient. It's also been quizzing me on PPPoE, which is great. I think I've pretty much got that down for at least the basic configuration. But let's get into a lab. This is about where I was when I started the weekend, and that is I'm still reviewing network lessons, shaping. So I have this basic lab right here. Again, if the construction of this lab, the design of this lab is not mine. This is from Network Lessons. If you want to see the configurations, if you want to see the lesson on shaping or QoS, definitely check out networklessons.com. I'm a big advocate of the site, and I've recommended it to others. I have no affiliation with them, but networklessons.com, you can do it by the month or you can do it by the year. I've purchased a year subscription, and it's been great. It's been a great supplement because, again, I've mentioned this many times before, there is no one single vendor that is going to get you through the CCIE. Derps Enterprises, have you studied Cisco Embedded Event Manager at all? I have. As a matter of fact, that was particularly difficult for me for the written, and it is definitely covered in the written exam. So I did I did perform a couple of labs. As a matter of fact, let me close this lab real quick. I think I may even have one or two in here that are from, yeah, the written. Make this bigger. So you definitely want to cover it for the written exam for sure. You want to know the different components of the EEM and what it can do and how it works and what its limitations are and restrictions for sure. That comes under infrastructure services, I believe. Yeah, so it doesn't look like, I have it here. Warwick, one of them is basically writing his own routing protocol with it. Oh, okay, yeah, it has a lot of capabilities. For sure. We do a lot of similar things like that in Azure. It's funny how, architecture, right? So in Azure, last couple weeks, we've worked on something that is similar to sort of an event manager. Azure has Azure Alerts and Azure Monitor. And essentially what you can do is anytime something is changed in your, in your tenant environment, basically in what you own in Azure, you can hook into an alert or a trigger. So let's say someone creates a new virtual machine, creates a new storage account. Azure knows everything that's going on, just like Embedded Event Manager, right? So you can tap into that and also generate some sort of event or a trigger based on those events. So for example, someone creates a new virtual machine and it has a certain tag. We can trigger an Azure logic app or an Azure network function or an Azure function to essentially run code based on information from that alert or that trigger. So someone creates a new virtual machine with a certain tag or under certain conditions. We run this code against that virtual machine, update, no matter who created it. If it meets a certain set of requirements, we will, join it to a Windows domain, for example, or create a local administrator account, or create a root account, or change the root pass, So it's really cool how that you mentioned EEM and its capabilities. A lot of that is built into the cloud as well. I'm behind your videos because I was studying for a hard exam, which I basically passed yesterday. GCI, GCED. I'm not familiar with that, Derps. You're going to have me Google it now. GIAC. Oh, this is a security. This is SANS. Very nice. SANS is a very respected. I've noticed that SANS was a lot about. I've followed SANS over the years, and they're heavily involved, of course, in like setting standards and communications, sort of publishing. But now I've noticed that they have more and more like offerings in terms of education and certifications and things like that, which is great. Congratulations, man. Always glad to see someone pass an exam. Good job. So, of course, you've got that momentum, Derps. What's your next target, my friend? Now that you have, you always want to celebrate. I'm a huge advocate of when you pass an exam, you put work into it, rewards. It's reward time, whether that's time off, steak dinner, buying a toy, and the family too, right? Rewarding the family. So, big advocate of that. You want to reward yourself, but you also want to ride that momentum. Awesome. CCI routing switch written. So, Derps, yes, definitely. One, that's great. I'm glad you're getting ready for the CCIE routing and switching. It is a very challenging exam. And you definitely want to know EEM for sure. That's an easy one to go down a rabbit hole in, I would think. But I would just know in your head, like, of course, you want to review the material that's stated that it talks about in the blueprint, right? But really understand kind of how it works. And it's important with EEM to understand. Knowing EEM means you need to know sort of what types of events that it will monitor in the system. So what type of processes run on a typical router or even a switch? What are some of those processes called? Especially, let's see, I think it's an iOS watchdog sysmon. And then there are proc CPU, and there's proc mem. This used to really trip me up because I would see proc mem and you'd think, well, is this? Yeah, you'll get it. No problem, Derps. It's just, especially the nomenclature to me is a little trippy on a Cisco router. So, for example, you'll see a trigger or an EEM applet that's built based on a event from iOS WD sysmon proc mem, and because it has the abbreviation proc in it, you think it has proc and mem. So which one is it? That's very confusing, and some of the boson would ask questions about this, and I would get them wrong because really this is, you have to just remember that there are two parts of iOS WD sysmon, CPU and memory monitoring. And when it says proc mem, even though it has proc in it, I think that's process. It's not processor. So yeah, exactly. So just know this is a memory event, not a processor event. That tripped me up. And that's based on a boson question I would get all the time. Boson's good for that. It has some good EEM questions in it that will get you kind of test your knowledge. And then of course the dreaded, let's see, what is it? It's the synchronous and asynchronous processing, right? Sync, no, sync, yes. Which is the default if you don't specify any. So be aware of those things. And then of course, yeah, those are some I can think of at the moment. But yeah, just really understand sort of your basic programming processing, synchronous processing, asynchronous processing. I actually did, Derps, I have a mind map, I think, or a process diagram in my notes. Topic notes, EEM. I have a flow diagram. Writing this out, yeah, skip is the other one. So sync and skip. You have a sync variable. Yes means synchronous processing. Emap and CLI command merge to a single linear process. And the CLI is paused between those processes, right? EM applet executes, then the applet completes or exits. And then if you configure the exit status, this is essentially skip. That's the other thing. The nomenclature on here is very strange. Oh, good. I'm happy, Derps. Yeah, man, I'm sure, I imagine you found it like I have. The explanations are so clear and easy to follow. And it's so customizable on the lesson because you can choose to do a lab or not if you want. You've got the configurations there. If you choose not to do the lab, you can just, there's usually a Wireshark capture that you can just download yourself. Yeah, so this really helped me. And again, I would say this would be, I'm happy to share it. It is shared. It's on my GitHub. But writing it out yourself is what really helped me. And then I have some examples here. Event CLI pattern, show text support, sync no, skip yes. So again, sync no. You know what symmetric processing and parallel processing. This is essentially asynchronous as parallel processing is what that is. Yeah, same here, Derps. It was a long time that, I'd kind of known about them before I purchased it. Hey, a network engineer, more taming of lambs. Yes, taming of lambs, baby. Good to see you. Hope you're doing well this Sunday. So yeah, sync no means parallel processing. The CLI command is not paused, but you still evaluate the CLI command with the skip, yes or no. So if yes, that means you're basically the CLI command is ignored that triggered this event. But the other processing that is part of the applet continues to work. EM applicant executes, applet completes, or exits. So yeah, I hope that helps. This is the original drawing. You're happy to take it, modify it, do whatever. And then this is JPEG. But that was one of the really very confusing parts. All right, so in network lessons, here we are. We've got lab, and then we've got shaping. And lab is already running. So what we've done is here is I've already... Okay, I wonder if these are still... Okay, these still work. Good. Trying to make these bigger. So what we have two Unix, two Linux boxes, Ubuntu. This is the built-in, Eve has integrated Linux images that you can just download and add to your lab. And that's what I've done here. That's the easiest thing to do because, as you can see, it's Ubuntu 16.04, long-term support. And we're running iPerf. So what we're doing is we have router 1, router 2, client and server. And we're imagining here that we control this router 1. And router 2 might be ISP, right? And they are policing. We're not, but let's imagine we were. So what we're doing is applying shaping out, right? And we're applying it out of the interface that this client uses to reach this server. And we've already done that. We've already applied it. So what I was doing is I've already gotten this far in the lab, but I wanted to do verification. And the reason we have this client and server so we can run iPerf, let me just show you the configuration we have so far. I think it's 0.1. No. Yeah, so we have output policy shape average. And if we do show policy map, we're using class iPerf, and we're using a committed information rate of 64,000 bits per second. So 64K, which is pretty small. We look at our class map. We're matching access group name, iPerf client server. So if we do show access list, so yeah, whenever we're trying to ping, well, any IP traffic from host 1.1 to 2.2, which is client and server, we're going to apply this policy. And we're going to shape the traffic. So what that's going to do, it's going to delay traffic. It's going to degrade the traffic meeting this classification so that it doesn't get dropped. We don't want to drop this traffic. So on the client, let me go over to the client. We're going to do, first I'm going to take this, I'm going to remove this policy. No service policy. Can I just do that? No, I have to do No, it wants the whole thing. So now we have no limitation, right? We don't have policing, but let's say we're pretending that policing, we have been told that we have been bad internet tenants. We've been bad clients using all our internet because we're like downloading, Napster. Actually, that wouldn't be the case anymore because, first of all, if you're downloading DMCA stuff, they will warn your ISP, and your ISP will warn you, right? But let's pretend we're like in the late 90s and we discovered Napster, and they've told us, okay, we're going to start limiting your internet connection. And we've decided, we're going to be good netizens here, and we're just going to do legitimate traffic, but we don't want it to get dropped. Let's smooth it out. So we're going to do iPerf here. Oh, let me make sure the interfaces are up all over. They are. These interfaces are up. And okay, 1.2.1.1. Okay. Yeah, I stopped that when Sony started to sue people. Okay, I can reach that, but do I have to do sudo or something? Connection refuse. Huh, I've not gotten that before. No. Could that be IP tables or something? This has not happened before in this lab. Oh, I know why. I know why. It's not running on server 2. Connection refused, but that's because I have not properly set up the lab. So we're going to tell iPerf to listen over here. iPerf S. Now it should work. Okay. All right. So these, of course, are not necessarily going to be in order when we get the results back. Hey, yeah. TCP window size, 85 kilobytes is the default. And it's supposed to send, 2, 3, 4, 5, 6, 7, 8. Okay. So at the end, it's supposed to do a summary once it has completed. And shaping is currently disabled. Let's see if I did that right. Yeah, uppercase P. Okay, so yeah, we should see on the servers where we see the summary, right? Once it finishes. I don't remember it taking that long. All right, while that's going, what I wanted to do here is look at the calculation. So one, we want to do our verification. Once here's what we're going to do, actually. So one is send traffic prior to shaping, establish throughput, apply shaping policy, send traffic after shaping, compare. and then verify shaping configuration, shaping formula. Verify, I want to do both. Verify the shaping formula. Looks like it's about to finish. Oh, it's coming back with the results. About 14 kilobits per second. That seems a little low. Oh, it's still applied. No wonder. I thought I'd removed it. What did I do here? I did no service policy output shape underscore average. That was on interface GI00. Ah, it's using interface 02. Okay. So we'll go the reversed, right? That's why it's slow. It's it's buffering. This is shaping doing its job. So the shaping formula, let's think about this. We have a 1 gigabits per second link. We have not applied a, because the way shaping works is essentially when you set a committed information rate, it looks at the bandwidth of the interface. So that can be either derived or it can be configured manually, right? In this case, we don't have an interface bandwidth configuration. So it's just going to use, the bandwidth is 1 gigabit per second, right? And let's see, TC equals BC divided by CIR. So time interval is going to be, I configured, let's see what, okay, here's our summary. The total number of megabytes and the bandwidth, 59.8 kilobits per second. It's summarizing, so it's adding. Interesting here that it's not really averaging it for you. I'm not sure. We're going to go through this output. We're going to go through this output and see. And this is on the client. What does the server say? 56.3. Yeah, it's going to be close, right? That just goes to show you, by the way, don't expect, you see a diagram like this and you think, well, these should see equal statistics, right? Not necessarily. Remember, there are different types of impacts on quality of service. So there's propagation delay, which is how long it takes the router to basically process the packet. Serialization. These are some of the things I've been learning, folks, and that I have as flashcards. So it is very possible to see differences here, especially in a virtual environment, but they are slight. All right, so let's take a look. The combined throughput of all connections. Customer clock rate, okay, of all connections, 120. So about 60 kilobits per second. And we have actually configured shaping here to be what? So let's do show service. Well, the best command here, I think, is show Show policy map for the interface. Okay, show policy map. So the axis class map, well, service policy output is shape average. And notice we have two classes here. We always have the class default, right? Which would be all other traffic besides what is specified or identified or marked by this class. This class is called iperf and it's match all. And Q depth 0, total drops 301, buffer drop 0, Q limit. So if we look at the number of packets, 1,862, the shape average is 64,000. So 64 kilobits per second. Traffic shape rate is 64, yeah. Show run section policy map. And that's what we told it. Do a shape average, 64123. Now notice we have not specified anything else. Because by default, if you put the rate, Cisco will calculate the rest for you, which it has done here. BC and BE are both 256. Interesting. Okay, so let's look at our committed burst is then, well, our CIR is 64123. So let's say Cisco then assigns, all right, so let me think about this. So if I put a, so for me to get the formula, I need one or either of these, you know, basic algebra, right? If you have a formula with 3 variables or values, you need at least 2. So I'm thinking if I put here, let's do policy map. I think the default for a gigabit interface, the default TC is 125 milliseconds, which is basically 1/8 of a second, right? But let's see that for sure. So shape average. Oh, hold on. Wow, this is interesting. So when I go into policy map, multivariable differential calculus. Oh my goodness, yeah. True. Class iperf. Ah, interesting. This is like a subclass, right? Then I can do shape average. Target bit rate, bits per second, 64123. Oh, okay, right. So I'm actually setting the TC. Which is, so the TC is 64123. No, 64,000 bits per second. So it's actually going to be 1 second is 64123 divided by CIR. $64,000 bits per 1 second. All right, so I should have enough here, right? They do recommend, Cisco recommends that where you have voice, that your TC be calculated at 10 milliseconds. Interesting enough. Show, we have a celebrity among us. Just popped in to say hello before we retire for the day. Go get them good bits. I'll be back online tonight. More labbing, my friend. Thanks so much, Show. Good to see you, buddy. And all luck. How many days we got? So, ooh, yeah. This is last big weekend, right? Good luck, my friend. Thinking about you. I'm considering the max size of the packet, 1500 versus 9000. You're talking about MTU? Talking about a Ethernet frame? That looks like the normal MTU for an Ethernet frame is well, it's usually wrong SNMP PDU digest. What that probably means, so what I'm taking out of that network engineer is, first of all, SNMP. So, and you have digest here. So, I'm thinking authentication. PDU is protocol data unit. So basically, probably you're sending, right? You're sending over a certain port protocol and port number, and it is expecting an MD5 digest, and it does not see the MD5 digest that it expects, so it is discarding the packet. Is probably what that means if I had to guess, to network engineer. Yeah, 1500 versus, so yeah, the jumbo frames is, I think, 90. You got a network engineer. A jumbo frame is, I think, it's going to be a factor, right? So it's going to be like a factor of 8. So it would probably be, it might be 9000. But your general MTU of an Ethernet frame is 1492 and 1500 for an IP packet. So, and yes, Show, in case he's already dropped, Show is taking a CCIE routing and switching lab exam on April 2nd. His first attempt, and we are all rooting for him. But he has been in the zone, man. He's been labbing like a madman, which I will be in that mode at some point as well. Yeah, I can see that, Derps, for sure. Probably depends on your chipset. Some might want to push that boundary even higher, right? There are RFC standards, and then there's the real world, where pretty much if you're a vendor, you can do whatever you want. Hi, yeah, nice Derps, nice emote there. All right, so shape average 64,000 bits per second. I want to get good at looking at a configuration and plugging in the formula. So we're going to say committed burst is 64,000 bits at 1 second. So what would our CIR be? Obviously, we have match packets on our policy map. Cisco IOS decided to use 256 bits for the BC. Yeah, because when we do a show here, that's the CIR. Okay, so I'm not matching. So if we have this is your basic formula, that means the CIR, if we TC times CIR equals BC. No, I want to do BC divided by CIR. So CIR equals BC divided by CIR equals TC. Let's just turn them around, right? So BC divided by CIR equals TC. Then if we say CIR equals, it would be TC times the BC. No, that's not right. I'm doing something wrong here. BC divided by CIR equals. So let's just go the long way here. Hey, we got a new follow. Marouge, thank you so much for that follow. BC divided by TC, right? So CIR equals, because all right, let me work this through my head here. I know this is going to go the long way, but let's say BC divided by CIR times the CIR equals TC times the CIR. That would leave us with BC equals TC times the CIR. Now if we reverse that, TC times the CIR equals BC. We could say CIR TC times CIR divided by the TC. That would leave CIR equals BC divided by TC. Is that right? It is, yeah. Hey, Sherwin, welcome. Hooray, you fixed it. Thanks, BC. Yep, thanks, folks. All right, so long way around, but this would be, all right, so the CIR is, in this case, 64123, which is basically equals to, we already know 1 second. And we also know sorry, yeah, you're right, BC. So this is bits per second. And we know that BC size is bytes. So what we have to do is to convert basically bits to bytes, right? Right, X would equal 64123 bits. But we have to divide that by 8. Because this is in bytes. So we got 1 second here, we got 1 second here, we can take those out. Equals how many bytes? We just divided by 8, which is 256, right? Let's see, calculator, where are you? Oh, finally. That's 8,000. So our burst BC would be 8,000 bytes, but that is not what it's saying here, right? Show service policy interface GI00. Show, I think it's policy map, and it's 02. This is BC of 256. $256. So what is 256 to 64,000? They must be doing something else here. All right, so if that's the case, let's work our way backwards, right? Let's say it's 64, 1, 2, 3 bits per second. This is what we have. I notice it also has a burst, excess burst by default. So what is 256? Hey, Burn12, what program are you using to simulate Cisco Packet Tracer? I'm using EvenG, which is with Cisco Viral Images. So yeah, EvenG is emulator. And these routers are running a Cisco image, and this is running, and I'm running it locally on in a virtual machine. Okay, so let me go back to it sounded like I didn't really have this down, so I think we're missing somewhere the default TC. The master, I don't think it is what Cisco is doing. Yeah, I think what I'm missing here. Let's see, what does it say the CIR is? 64. So I think we're operating off of the time interval of 1 second. And the default time interval might be, let's see, Cisco doesn't have a history of asking weird math problems. They just keep it simple. Yeah, of course. So let's start with this one. This is one that I went back to the previous network lesson where it talks about these formulas. And of course, BC is going to equals CIR times the TC, or TC times the CIR, right? So in this case, we know the BC is 256 bytes. And we know the CIR is 64123. So if we do, if we want to get the TC, the time interval, that means we'd have to do 256 divided by 64123 equals TC. And I think I just 256 divided by 64123. 0.032 seconds. You have to convert 64,000 to bytes. Yeah, this is where it always gets fuzzy for me, because we're taking two different, we're using two different units of measurement. So what if I convert that to bits per 1 second? Yeah, I just lost myself here. All right. Most Cisco routers have a TC default value of 125 milliseconds. Yeah, I think that's where I am going wrong. Sure, so you have TC equals 256 bytes divided by 64,000 bits. I think you're onto something, Sherwin. So let's follow your train of thought, because I think the whole part I'm missing here is that the TC default on a Cisco router is 125 milliseconds. So let's go back to this, right? Let's say TC equals 256 bytes divided by 64123 divided by 8. Bytes. TC equals 8,000, right? 256 bytes divided by 8. 8,000 bytes. So 256 divided by 8, 123.32. No. I was just thinking during an exam, yeah. I just was thinking about it, would seem weird. All right, so I think what's happening here is this. So let's go back to, assume TC is a constant, is 125 milliseconds. Unless you change it. Most Cisco's routers have a TC default value of 125 milliseconds. And so let's make a flashcard for that, by the way. That's an important point. See, I'm all clear for today. Woo! Default TC of a Cisco router, 125 milliseconds. Okay, that's the part we're missing. So let's go back to our formula. TC equals BC divided by CIR. So 0.125 equals, let's say we don't have the burst size here. We want to calculate for the burst size. And we want to say the committed information rate, like the interface speed is 1 gigabit per second, but we want to drop it down to 64,000 bits per second, right? In other words, 64 kilobits per second. So what do we do here? To calculate our BC in bytes, we need to do 0.125 equals x divided by 64123 divided by 8. Because we want to get to bytes, right? So 0.125 equals x divided by 8,000. So we do 8,000 times 0.125 is x. Yeah, I did something wrong here. All right, let's go the other way. Maybe this will work. We know that BC equals TC times CIR. Discrepancy between this total and the total showing the output of the show policy map can be attributed to a rounding calculation or the difference associated with a specific interface configuration. I think there's something else going on here. So BC equals 0.125 times the committed information rate, 64123 bits per second. Oh, okay. So BC will equals here's the crux, right? BC is in bytes. And we want to know how many bytes in basically 1/8 of a second, right? So what we're going to do is we're going to say 64123 bits divided by 8. Look at BC bytes, 125 times 8,000 bytes. Yeah, so we're basically wanting to send 8,000 bytes per second, which would be 64,000 bits per second, right? But our TC by default is 0.125 seconds, 125 milliseconds. So BC is going to equal times 0.125 would be 1,000 bytes. Hundred 125 milliseconds times 64 kilobits per second, 8,000 bits, or 1,000 bytes, right? What did I configure here? That is 1,000, but that doesn't show policy map interface GI02. CIR 64123. 64000. But this BC is 256. Show run. Shape average 64123. 64000. All right, thank you, Derps. Hey, I'm Mog. How are you? This is saying 256. So what is... Today, we're working on shaping, QoS, quality of service, and shaping. TC max, so you can calculate a max value of BC. Oh, you know what? This is bytes per second, isn't it? No, we're using 0.125 here. Oh, okay, okay. BC is in bytes, that's correct. It doesn't seem like you want to convert bits. It seems you want to multiply BPS and the time in milliseconds, then to divide the result by 8. Yeah, it's funny because I'm going by this example in network lessons. We want to use milliseconds, don't we? Scroll to the bottom. Oh, okay. Let me take a look at this document. Thanks, folks, for the help. Of course, it's behind a login wall. Nice. Cisco, you are shameless. Calculating the CIR. Formula for calculating committed burst. Oh, this is a router. We're not dealing with VLANs, really. Math gets tricky and I need help with it all the time. Oh, me too. Once I understand, obviously I don't understand the formula. And that's what I'm trying to drive to, is so that I can really, once I understand what it's doing. So let's take this example here. Let's scratch what we know. All right, here we have this interface. I see what you're saying about the rounding. Yeah, no problem, no problem. The BC in milliseconds. Now, is this policing or shaping? Policing and shaping. Yeah, you have to be careful because policing uses a much different, has a much different design, or the engine works much differently than shaping. And what's interesting here is this is kind of useless, this Cisco, man, documentation. Don't get me started on Cisco documentation. This article says QoS Policing and Shaping Configuration Guide. Guess what? There's no shaping in here. They were just teasing. They don't really mean shaping, even though they say shaping. Unless that's the name of the book, and the book has, okay. Still, the structure, whoever designed the UI for their documentation is just law of Cisco docs, exactly. Hey, working out BC values quickly. This looks promising. This is routing bits. Who is that? Do I know this? Where's your about? Oh man, lag, spam lag. Time to switch to Opera. Come on, bloggers. Please don't spam me with ads. Do I still have Brave? Don't. Okay. I was just trying to go to your about page and you're like, okay, so dictates the output rate, one aims to average, right? Okay, interesting. Book formula is CIR equals BC divided by TC divided by 1,000. To work out the BC value should be, you need to decide what your TC should be. Ad block plus. Yeah, I've thought about it. That's not free though, is it? Derps. You need to decide what your TC should be. A big decide is the most used important application for data. A larger TC is generally recommended. For voice, you want the smallest possible TC to avoid pat. Right. Very true. I do understand what he's saying here. First, let's calculate the TC of 128 milliseconds. So I like this formula. Let's see if we can use this. So our TC, we're going to assume it's 125 milliseconds, but let's look at what Cisco has here. The BC in our lab, too many screens, so many screens, is 256. Wait a second, where did this come from? That's right. So 256 divided by CIR of 64123 times 1,000. .004, right? before. That does not sound right. 4 seconds? No. Okay, first let's calculate using a TC of 128 on a 512 PVC, or 125. So he's using this formula, BC, committed burst rate. All right, let's put all these in here. These are called the book formulas, right? The CIR is this. And he's saying, all right, here's an example. Yeah. BC is the number of committed bits allowed to be sent per interval to conform with the target rate per second. If BC worth of bits are sent every interval in a second, the output rate is the CIR. Okay, based on a second. So he's putting in here, firstly, let's calculate using a TC of 125 milliseconds on a 512K PVC. So BC equals times the TC of 125 divided by 1,000. So that makes sense, right? Because it's saying we have a 512K PVC. So if we think about how much is that? 512? 512 is our committed information rate. 512 bits per second. 512,000 bits per second. So 512K is like half of a gigabits per second, right? It's close. 1024 divided by 2, so that's 512. So let's say we have a gigabit link, but we have a PVC that is 512K. So we want it to essentially, we're going to give that PVC, allow it to burst to use like half of the link. Makes sense, right? 512. So let's see this formula. And we're saying our TC, 125 milliseconds. Okay, so 125 milliseconds, we're trying to calculate per second, right? So that's why we're dividing 125 by 1,000. So let's do the math here. 125 divided by 1,123 is 0.125. Okay. 64,000. Okay, cool. All right, that makes sense. So in other words, our burst is going to be 64,000 bits at the start of our TC of 0.125. So if we do that, 0.125 means that we would send 64,000 bits 8 times. Yeah. So if you see, like in the lessons, you'll see this, right? we have the burst, because we always send at wire speed. So we're going to send a burst of 64,000 bits, burst of 64,000 bits, burst of 64,000 bits, wait, burst of 64,000 bits, wait. And that means that within 1 second, we will have sent 512,000 bits. Yeah, that's where I get so confused, derps. This person is converting from milliseconds to seconds. Just another way to do the same thing. I like it. I do too. I think this is kind of opening it up for me. So everywhere here, he's converting to seconds, which I like. Very nice. All right, let's say we want to do, I like this. So we want a TC of 10 milliseconds on the same PVC. So instead of 125 milliseconds, $512K, and our TC is going to be 10 milliseconds. So how much do we send every 10 milliseconds? Include units to prevent confusion, says Derps Enterprises. So true. And that's when Show IP Interface Brief and I were talking about this earlier. It's like we're using different units of measure here. And this formula takes that into account. Okay, so BC, in this case, this is our CIR, and we have our TC. So this time we want to do BC equals 512 times 10 divided by 1 second. See if I get this right. Uh, 10 divided by is 0.01, right? Wait, did I do that right? 10. Yeah. 1/100th of a second times 5, 1, 2, 1, 2, 3. 5,120 bits. In bytes, that would be 640 bytes. See if I got it right. It is not difficult. This usually needs to be worked out on a piece of paper. If you're lazy like you want to work it out in your head. I do this by simplifying the actual formula. To get the BC value, I use the following formula and work out the result much quicker. Cool-Rigger, oops, I forgot to divide by 8. Yeah, I did too. All right, so let's see if this, before we learn another thing, let's go to our, we know our CIR on our lab is 64123. Right? Six, 4, 1, 2, 3, right? I keep saying 1, 2, 3. That's for how many zeros? Sorry, that's misleading. 64,000. And again, you can look at this and say, oh, this is bits and that's bits, but this is bytes, remember? So 64,000 bits per second. And our BC, we know, is 256 bytes. So first of all, we have to get these to be the same, right? TC equals, and usually with this math, we put it at bits. So BC is going to be 256 times 8, 2048. Oh, sorry. Yeah, TC, we're kind of solve for TC. TC equals 2048 bits divided by the CIR, 64,000 bits per second, times 1,000. So it'd be 32 milliseconds. But you know, it does not show us the TC here. It does, because if you do 32 milliseconds, how many intervals is that in 1 second? That's approximately 30 intervals. So at every 30 intervals, we'll send 256 bytes. Let's see if that makes sense. Let's go to this formula. BC equals 4123 times 32 divided by 1,123. So 32 divided by 1,000 is what I just had, right? 0.032. 32 milliseconds, right? 0.032 makes perfect sense. Times 64123 bits. And in bytes, that would be 256. The router is not wrong. Okay, all right, so that is helpful. That is helpful. Whoever this is, routing bits, thank you very much. Who posted this? Sherwin. Thank you very much, Sherwin. That was a great post. All right, so apparently there's a way to do this faster. And what surprises me here, folks, is this TC. Where did it come with 32 milliseconds? Like the router, I think by default, would do 125 milliseconds. But we are using the shape average command. Oh yeah, you're welcome. Yeah, appreciate it. All right, it's not difficult. This usually needs to be worked out on a piece of paper. If you're lazy like me, which I am, yes. Want to work it out in your head, I do this by simplifying the actual formula. BC equals CIR divided by intervals per second. Bookmarked, added, yes. In fact, I'm going to put it, I want to remember this. That's why they go here. Formulas for QoS. All right, so the shortened formula is this: BC equals CIR divided by intervals per second. To get the intervals per second, it'd be 1,000 milliseconds divided by TC. 8 intervals. I like that. I like that it's actually showing the number of intervals. So in the same case, our example that we're working with here, BC equals 64123 divided by 1,000 divided by 32. Yeah. I'm not sure of how that's easier. Probably need a little practice. Okay, what's throwing me off here though in this lab is this is a shaping example, but it's the shape average command. And there's a note on here that says we will go for the shape average where we have to specify the target bit rate. Let's go for 64 kilobits per second. And you notice here, if we do the command again, policy map, show policy map shape average class iperf shape average target bit rate. So we can do a percent or we can do a bit rate. And notice our options here are from 1,000 bits to a billion bits. And so I'm going to put 64123. Now this is interesting, right? I'm going to screenshot this. Bits per interval sustained. Recommended not to configure. Algorithm finds the best value. But I could configure this. And let's see, if we did 2048, it would be the same. And this is our excess burst, 24. If we want to get 256 bytes, it would be also 2048 bits per interval. Now let's do show policy interface GI02. Oh, hold on. That was bits, not bytes. Now I'm a little confused. I think this must be because it's not using show policy map. It is bits. Is that just an image thing? Because like the documentation says that BC is in bytes. So I was assuming incorrectly. Let's go back to our formula here. Let's remove the configuration. Policy map class iperf shape average Yeah, probably depends on iOS version. So this is bits. So in this case, BC equals, I'm going to, until I get a grasp, I like these formulas. I'm going to stick with this. We already know the BC. We're trying to solve for the TC here. TC equals 256 bits. Go back to that link. Eight milliseconds is the smallest interval you can use. Okay, that makes sense. On distributed platforms, 4 milliseconds. BC is the number of committed bits allowed to be sent per interval. Maybe I'm thinking of policing. Maybe I'm thinking of policing. I must be, because this is definitely bits. So let's say TC equals 256 bits divided by the CIR times 1000. So TC equals 'It doesn't make sense. TC equals BC divided by CR times 1000. I copied and pasted that, I believe. Yeah, the BC is 256. Six, four, one, two, three. Yeah, that's a small number. Four seconds. That doesn't make any sense. Oh, interesting. So 4 milliseconds. Oh, 4 milliseconds? Ah, right, Sherwin. Yes. Not 4 seconds. Okay. So what we need to put here is I'm going to add this. BC in bits and CIR in bits per second, right? Equal to BC in bits divided by TC in milliseconds. Yeah, okay. That's the last little bit, I think. Divided by the CIR in bits per second. Okay, this should help. Again, it comes back to units of measurement times TC in milliseconds. I think this is going to help me for a while, just to go off of this. Right? So that makes sense, because this is actually the smallest you can configure on a distributed system, 4 milliseconds. So every 4 milliseconds, it will send 256 bits. That means that, how many intervals is that in 1 second? Why do I keep closing the calculator? To get it out of the way, probably. So we're going to have 250 intervals times 256 bits, 64,000 bits. There it is. Okay, so I don't want to get news alerts right now. Cool. So there it is. All right, I think this will work every time. So let's go back to our lab. And the known quantities here, it's interesting. There's a note here that says that on newer platforms, when you do a show policy map, it does not show you the TC value that Cisco used. On older platforms, it does. It shows you a lot more detail. So let's see what Cisco used here. Equals the BC in bits, which we know is 256. Oh, we already know this is 4 milliseconds. Yeah. We got it. That's it. Okay. So what I'm going to do is I'm going to create an Anki card here. 3 of them. Extended formula for calculating shaping TC. TC in milliseconds. We're going to do this right here. And we're going to show an example. And this thing is going to make, this Anki is going to make me review this several times in the next few days until I get it. So we'll say, for example, in our example, TC. You know what? I'm going to put a couple problems in here too. QoS. I'm going to put a couple problems. Extended formula for shaping CIR. And extended formula for burst size. Perfect. Okay, solve the TC. Solve the shaping TC for a CIR of 64 kilobits per second and a BC of 256. So to solve for that, I'm going to put this in this formula. TC equals 256 divided by CIR. Is that right? 256 divided by 6412. Yeah. Boom. Okay. And I'm going to close calculator now. And I'm probably going to take a break in a moment. It's getting close to dinner time. This is good. Again, I did not want to move on from this lab until I really understood this. Oh, wow. Okay. The network lessons, yeah, 4 milliseconds confirmed. Okay, so what I'll do is it continues in the lab too. There's other things I have to do this evening, by the way. So I doubt I'll be able to get to this today, but we'll tackle it probably tomorrow. And the rest of this lab is going through and changing some of the values. So that'll be a good review tomorrow and a good learning session. So probably wrap it up here, folks. Thanks so much for stopping by. I appreciate it. Appreciate y'all hanging out with me, and thanks for the link, man. The link saved me. Also, the other comments were very helpful. So good job. Good job sending good bits out to everybody. You can follow me here on, of course, on Twitch. And if you're an Amazon Prime subscriber, you may or may not know that you also get one free Twitch Prime subscription a month, which, you feel free to use here if you like, if you haven't used it. Hey, you all do the same. Thanks so much, Derps. And also, you subscribe to me or, follow me on Twitter, subscribe to me on YouTube, and on Instagram. And we shall see you back here tomorrow night, our normal time, weeknights, 7 p.m. Eastern. We'll see you then. And until then, send you all the good bits that we can. Take care. Have a great rest of your Sunday.